Hey everyone, I hope I am audible now. I'll just give one more minute if anyone else is joining, and then we can start. Okay, I think we can start now. Welcome everyone. So this is basically another set of webinar that we have been sharing from CASIA side. Uh, this webinar is all about applications that we build and that are deployed on cloud specifically. There may be some factors that will be relating to mobile applications as well, but it's a general set of principles that uh, that can help anyone who is developing some piece of code and writing the software. Now, before getting into this, there will be there will be set of things that I'll be covering just to give you a high level idea. So what 12 factor app methodology is, then key principles or all the factors that are included in it, benefits that this particular principles or these set of principles will provide if implemented correctly for any web app, then there would be some implementation tips respective to each factor and how you can utilize it. Now, before getting into it, what is the need of a new set of principles or new set of guidelines, new set of tools? Today, in most of the systems, most of the applications are built cloud specific or cloud native, you can say. There are applications that utilizes cloud storages. There are applications which rely heavily on cloud. So if you have your data located in one location, your application can't scale, right? If you are keeping all the data at your local, your application or your software can't scale. So obviously the next choice is to have everything on cloud. So databases on cloud, file storage is on cloud, then compute on cloud as well. The challenges that typical systems face is that our distributed systems, so there are now when we talk about distributed systems, it means that there are computations that are happening at cloud at different locations, then storages at different locations. Now, most of the organizations, or I would say 90% of the organizations, report issues while managing those distributed systems. Now, the type of issues could range from ensuring that security is intact, ensuring the right versions are uh, patched or updated properly, and ensuring that performance issues are not there. Then there are cloud scalability issues. So when the applications are deployed on cloud, again, about 85% of apps fail to scale, which means that today, if you are building your application or your system, uh, you have written some piece of code that is working well. Now, if you start seeing a surge in traffic or surge in number of users who are using your system, many of the cloud systems starts failing. Either the fail could be in the performance, the fail could be in terms of cost that is associated with it. Uh, and again, about 80% of the upspeed. Next challenge that we see today is continuous delivery. For example, if you are making a software and then there are new features that are requested by clients or customers, then there are uh, maybe new patches that you require to introduce in your system, patches in terms of security patches, in terms of bug fixes. When you go to the process of delivering those changes, most of the systems or most of the setups, again, they see a huge amount of delay. The delay could be because of there is a lot of dev cycle, then there is a test cycle, QA cycle, then there are automated type pipelines if there are any. If there are no automated pipelines, there could be manual testing, manual QAs, and there could be a wide variety of range of users that would might be using the system. So that delay is something that many systems face today. And security and config management is another aspect. There are multiple applications where you you see then there is a breach happened recently. So there could be breach happened due to a lack of proper security in terms of environment variables. There could be a breach in security or application is compromised because the developers are not aware of good coding practices, secure coding practices. Then there could be multiple challenges, other related factors as well. But here, the challenge that we are trying to address using 12-factor methodology would be the config management. A typical downfall here or typical pattern that is seen in traditional systems is uh, when you want to write some code and you want to, let's say, integrate to a database, connect to a database multiple times, and that happens in many organizations that developers tend to hard code the credentials. And that is a very, very bad practice. Now, how would fill factor help in addressing those? First of all, let's try to understand what fill factor app is. 12-factor app is a set of principles that were laid down by developers at Heroku team. Heroku, one of the uh, cloud service providers, not quite popular as compared to AWS or Azure, but they have been doing quite good in terms of how they are managing their services. They have laid out some set of principles that, if followed, can ensure some level of scalability, some level of performance benefits, some level of continuous delivery benefits, which means you are rapidly able to uh, send out features, send out releases, some level of security. There are obviously like different other things that you need to ensure uh, your application is fully secure, fully performant, but it gives a general set of principles that can be followed. Now, uh, what it will address is it will be cloud native ready, then microservices friendly, DevOps driven, portability. Now, what do we mean by cloud native ready? Which means that any application, any software that you're building today, if it is using cloud systems at some point, these set of guidelines fit perfectly for you. Microservice friendly, which means that if you have a system that is decoupled in different services or different processes, then these set of principles also conform to that, or it is also able to address the implementation of microservices as well. DevOps driven, it means that you break your steps for build, release, and other securing your applications from an operational standpoint rather than relying completely on developers. We rely on the processes that we lay down. Then portability, so it can help us in working with different environments seamlessly. Now, again, before before getting into all the factors, it would seem a little bit confusing, but once we get into that, it will become more clear. The initial factors, starting with the code base. The first factor is says that one code base tracked in version control, many deployments. Now, this principle requires you to manage your code base in a central repository, which for version control, rather than relying on the fact that every developer is working in a silo, and when they want to test their features together, they share this zipped version of code. Now that is an NT practice or NT pattern. The first factor clearly says that we need to have Git or maybe Subversion or maybe Mercurial or maybe some other version control system which acts as a central repository for us, and we manage different versions of the code base there rather than having different copies on our local. That is first principle. Why it matters is because we can ensure consistency across all the environments. For example, if I am having, let's say, a dev environment or a QA environment that one developer is working upon, if we are managing code base in a central repository, which is having different branches, obviously, if we are talking about Git, we can consistently make changes across environments rather than every developer working on their own silo and then suddenly they see there are a huge amount of differences in their code business. That is first factor. Obviously, like it's quite simple and it's de facto today that we need to use Git. But then there are many developers who tend to fail in understanding how the Git should be structured, how we should be using properly version controls. Now there are different branching strategies or version control strategies as well. And everything can be like searched and checked. But if I talk about it at a high level, we tend to create main branches, which is main, develop, QA, staging based on our environments. Then there could be feature branches, which relates to specific features that you are working upon. Then there could be bug fix branches, which relates to the branches or the code base or the bugs or the tickets, basically, that relates to bug fixing. Then there could be hot fixes branches, which relates to hot fixing or fixing bugs in the master branch or making any changes to the main branch production system. At a high level, that's what it is. Now, there are tools that we typically use: Git as a service in our local machines, and GitHub, GitLab, Bitbucket as the example service providers on cloud. First factor, so you should be having a code base which is tracked in version control, and we can control the deployments from there instead of keeping it on local or in an independent silo. Second factor says talks about dependencies. Now, many of these frameworks, tools, systems, most of the tools that we see today mainly utilizes, if we talk about Node, we have package.json. If we talk about Python, we have requirements.txt. If we talk about Android builds, we have Gradle files, and then POM files for Java. So there are a different set of files which are enforced by the framework today that are available. Now, the second factor basically says explicitly declare and isolate dependencies. Now, explicitly declaration is enforced by the frameworks today, although we just need to ensure that we are specifically defining our dependencies or anything, any functionality that we want to leverage in the code, specifically in our respective files. Again, this also ensures and also says and requires you to don't rely on the host OS to provide certain services. For example, if you want to leverage connections to database, you should be explicitly installing the dependencies that are facilitating your application's connection to database. Isolation of dependencies, it typically says that if you are installing some dependencies, those should not be conflicting with the dependencies or applications that your host OS is providing. For example, in Python, there is concept of virtual env or virtual environment, where if you are downloading the dependencies, it is created in a virtual environment that is completely separate from the environment of your host OS. All the dependencies, all the packages that host OS may be having, or maybe they might be installed by someone else for something else, the project specific dependencies won't be conflicting with that. That's whole about this factor. There could be, if we talk about best tips or tools, there is one particular implementation that is suggested for dependencies for isolation is Dockerization. Now, if you are not aware of Dockerization, what it does is it isolates your build environment or packaged environment. It helps in creating your images which are specific to your application, which I would say also keeps all the dependencies alongside that image, and you are able to run those images in a complete standalone environment, which is independent of your host OS. So that is called containers in terms of Docker. So you are able to create containers where you have a different set of dependencies, different set of let's say installations, any package that you want to install there. It runs in a different container and it is isolated. It's not going to impact or conflict with the dependencies on your host OS. That is what the isolation means. So if we are not going with Dockerization, although that's highly recommended, and you will see that I will be recommending it during different factors as well. So your application should be containerizable. So it should be able to run in a different silo or as independently. Then dependencies should be declared explicitly, be it in your package JSON, be it your requirements JSON, be it your Gradle files, be it your POM files, wherever. Like the framework services for NPM, PIP, Maven, Most of the developers are familiar with it. If not, these are the terms that you can refer and maybe use down the line. Coming to a third factor, that is also relates to securing your systems. So it says that your configurations for a particular environment should be kept separately instead of saving it in code. Again, as I shared while talking about the security issues, so the hard coding of credentials, be it port, be it the service endpoint, be it any, let's say, environment specific value, be it API URLs, be it anything, we should be using specific env files or environment files and should not be hard coding in code. That is again third factor. It seems obvious, it looks like obvious, but it is also true that many developers fail to ensure that these basic set of requirements are met. uh, uh, the factors are basically met. There is no specific details, no other details that are needed for configuration. It just means that you need to ensure that you are maintaining it in environment files. There is one step ahead that we can go is when we are talking about cloud native systems. Most of the cloud service providers provide a secure storage or secure key management services or secure secrets management services. For example, in AWS, there is Secrets Manager. Azure, again, we have uh, credentials managed, I believe. Then there is similar for GCP as well. So we can save our credentials there, which means that in any case, even backend is fetching directly from that storage rather than files. That storage is encrypted by default. You can specify your encryption keys and all, but it is secure. It is at a central location and it is highly secure. That is one step ahead. Now, for different frameworks, AWS Secrets Manager, as I said, HashiCorp Vault, Vault is a service. Then Kubernetes Secrets. Again, these are the services that are offered by different frameworks uh, to manage your secrets in a highly secure manner. But again, coming to the conclusion, so you should never be hard coding credentials, never be hard coding configurations. Always and always choose to keep your configurations aside in your environment variables. Coming to the fourth factor in 12-factor apps, uh, it says that treat backing services as attached resources. Now, the question may come, what are backing services? Backing services are basically where your data is being stored. You are doing some processing, for example, sending out notifications, which are using from a different service, or you are caching something, which is again using either memcached or Redis. So it says that all the backing services, which are not part of your main functional logic or business logic, those should be treated as attached resources. What does it mean? Attached resources, it means that it should not be with your application itself. It should be configurable and we should be able to connect to it via environment variables. So in typical implementation example for developers, as I said, in configuration, we move all the environment, all the configurations in different env files. So in this example, for backing services, we would be specifying our DB credentials there. We would be specifying our Redis endpoints there, or Redis connection endpoints there. We would be specifying, let's say, we are using MailChimp for email notification. So we would be specifying the MailChimp endpoint there. So all the backing services should be treated as attached resources. And if your service is running, uh, uh, if your process is running, or if your application is running, and it, let's say, gets closed due to any reason, it gets killed due to any reason, your backing services should not be impacted. Whenever a new version of your application is up, it should be able to connect seamlessly to those backing services. That is again a important factor. So examples are given as S3, MongoDB, as I said, queues, databases, caches, maybe notification sending services, and all. What it ensures is, if due to any reason your process fails, as I said, your backing service will still remain same. In one of the next factors, you will understand why I am referring that your application fails and new version comes up. But it will ensure that your application has a state that is managed somewhere. If we are talking about databases or files, uh, or functionalities in terms of a different service, and your application can shut down or spin up gracefully. That's the point of this fourth factor. Fifth factor talks about build, release, and run. So as we were seeing in the first slide, so it was mentioning about DevOps specific, so DevOps oriented. So fifth factor says that your build, release, and run should be isolated with each other. Those stages should be isolated. What it means is for a, let's say, application, node application, when we are building it, we typically do npm install. Or when we talk about the Python application, we install all the dependencies from requirements file, which is PAP install. Now, it says that the build stage, it could not be limited to this these installation steps itself. It could have multiple steps, be it test stages, be it maybe sonar or quality gate scans. It could be linting scans as well. It could be PR reviews. So we isolate our build process to release process and then run process. Now, what would come in release process? Release process means if we are talking again about node application, let's say we are using AWS and we want to deploy our node application. There are various ways of deploying. It could be directly on an EC2 instance. It could be on ECS services. It could be deployed as Lambda functions, right? There are various ways of deploying a node application. Now, it says that building of a node application or packaging it itself should be a separate step. Releasing, so releasing either using Jenkins, releasing it using code deploy. It could be a different step. Building could be using code build. Again, Jenkins is a tool which facilitates building, deploying, and maybe initializing the run. It don't run it. Running is ultimately done on the host infra, but building and releasing it can handle. So you isolate your build, you isolate your release, and isolate your run. Run is in any case in cloud native environments, it is isolated. So if you are having, and let's say an ECS service, which is a containerized service, as I was talking about Docker. So AWS provides a service which is Elastic Container Service. It helps you to run Dockerized images in an isolated environment. So running is again isolated. Building is isolated using separate stages in your CI/CD process. So you build it, all the packages are built. Now, once everything is built, you have an artifact, right? That artifact needs to be pushed to somewhere. So AWS provides Elastic Container Repositories if we are talking about the Docker images. And you build it, you push it, and it remains there as a different version controlled manner. So it could have a, let's say, version 1.0.1, or then you make some other changes. It could be 1.0.2. So both the packages or the artifacts with different versions will remain there. It's a repository for all the artifacts or the containerized artifacts that can be utilized to run a containerized service. Now, build, you have isolated. Release, you have isolated. Why I am talking about release as isolated processes? Let's say you have deployed one version. Now, you suddenly see that there are some challenges, or then there are crashes, or maybe some blockers in the deployment. You should not be building the application again because you have a repository of all the different versions. So you should be able to just go to the console or maybe CLI and then change or point to a different version that you had previously and just run it. So what it will do is it will save the build time, because let's say if we're talking about a very simple application that can have maybe hundreds or less than 100 dependencies, it will take still up to 2 minutes, 3 minutes, 4 minutes of time. And ultimate goal is to ensure that if some users are blocked into a deployment or a particular version, they should be unblocked as quick as possible. So what you do is you just point to a different version and run that instead of building it again, releasing it again, and running it over that. Now it solves one of the big problems that I was talking to previously as a challenge. Now it saves the dev, QA, and release cycle, because you already have a version which is there, which was stable, which was tested, which was released, and you just point to it and everything just runs. There are some, I would say, corner cases as well, because there could be database changes, there could be some schema changes, there could be other configuration changes, or there could be other things, right? We will talk about that when I get into QA round. But again, there are ways to handle it. The examples that are given here is GitLab CI, Jenkins, code pipeline, again, all the artifacts we are generating and ensuring that tagging is there uh, to ensure that if one version fails, we are able to roll back to a previous version quite quickly rather than following the same PR review cycle, dev cycle, QA cycle. That's fifth factor. Fifth factor means your build, release, and run stages or cycles should be isolated. Coming to the sixth factor, which talks about processes. Now, uh, it says that applications should be stateless and share nothing. Now, what does it mean to be stateless? Let's take example of a node application, which is doing some processing, right? Let's say increasing the count of a number. Now, there are various ways of doing it. You can store that variable in a global variable in the code itself. You can store that in Redis. You can store that in database. You can store that in a file. All these ways. In first a way where I'm talking about the variable within the code itself, it it means that you are storing some state within the code. Now, node application which is counting or incrementing it, the factor says that it should be stateless. It should not be having any state with it. So if one user is accessing this application, the other user may be at a different location, he should be, if he is accessing the same deployment rather than, uh, yeah, if it is the same deployment, so the variable would have the increment and all. But let's say your service goes down. What happens to that count? Instead of count, it could be user session. It could be uh, uh, let's say number of logged in users. It could be anything, right? If your application goes down or your process or your service that is performing the computation goes down, you don't have a way to retrieve that state. So it says that your applications or your processes which are involved in compute or which are involved in implementing a functionality should not be having their states maintained within them. So where should we maintain the states? Your state should be maintained again in the backing services, as I was talking about, and backing services should be connected to your application as an external entity or as a connected service, which means you should be having your environment variables for it. You can use external storage, which is example databases. Your S3 storage, you can use Redis to manage all the states, and all the states should be managed outside your application. It should never be maintained within the application. The process being killed again, you will come to realize that I think that is mainly mentioned in this factor, but I'll come to that later. Uh, so the factor 6 says that your processes, your application should be stateless. They should be sharing nothing. So whatever they have, they should be passing it directly to your backing service where the state is managed, and you are able to retrieve it, update it, modify it, and your application. If your application goes down, the state is preserved. The state is intact, be it your session, be it your count, or be it anything. Right. Coming to seventh factor, it says that export services via code binding. What does it mean? Now, let's take example of one server that you're running on your local machine. The server being localhost. Now, there are various applications that are running on your machine. It says that your applications or your services should be bound via port. They should, no one or the external entity should not be guessing the port of your application. You should be exporting or exposing specific ports. For example, if you are running, if we are talking about HTTP endpoints, which is for HTTPS. Now, typically in most of the HTTP systems, it is expected. So if your service is a web application and it is providing some responses, it should be having port 80. Now, it doesn't mean that you have to run your application on port 80. What you can do is you can have your application running on, let's say, port 3000 for node applications. It could be 3001, 2, 3, 4, 5. It could have multiple applications running on that same machine with different ports exposed, and outside of it, all these services are exposed on port 80. So as an outsider, they are just reaching out to port 80, and your internal services are exposing their respective ports. So it could be 3001 for one application. Your front end could be running on, let's say, 3002, if we are talking about the same application or same machine. You can have a Redis running on the same machine. You can have a database running on the same machine, but you are exposing them on different ports. And for an outsider, you are specifying that these are the ports that can be leveraged to access it. Although it's a little bit confusing if we haven't used single machines for all the deployments. But yeah, it is quite important as a factor that we should be exposing our ports rather than assuming or letting the other one guess which port it is running on. So if whatever port your application is running on, you expose it to a needed port, be it 80 port if we are talking about HTTP services, or if you are having, let's say, Redis installed on that and running on 6379 port, or maybe some other port, you expose it to 6379 so that as an outsider, these are the standard ports for these services. They are aware that this is how you can connect to it. For Docker systems, there is a flag that I've mentioned. So P flag, you can specify the ports that outside port or internal port. You can specify -p even outside external port that this particular service is exposed to, and the internal port where the traffic will be routed. Again, the pointer says that don't hard code ports. Again, that belongs to the factor which says the configuration should be in your environment files. Don't hard code anything. Examples are given: Docker, Kubernetes, Express, and Spring Boot load balancer. So you can specify the port forwarding in these services. For Docker, P flag. For load balancer, you can have your targets and target rules. Spring Boot, you can do that. Express, you can specify your own port while running your application where the application is going to run. Eighth factor says concurrency. Now, let's say I talked about having a significant load suddenly on your application and it suddenly started getting traction. Now, there are various ways of handling that additional load. Your systems or your services, let's say you had two vCPU, or if we talk about in general terms, you have two vCPU with 8 GB of RAM and let's say 500 GB of storage. Now, suddenly there is a spike in number of users who are trying to use your application. There's a one way you add in another set of RAM, another set of memory, storage, and maybe increase the CPU as well. So that means you are scaling it up. You are increasing the underlying capacity of that system. There's another way of doing it is you provision another system with similar configuration or maybe different configuration, and you run your application there in parallel. So you keep it connected. Now, how to ensure that your application is running parallel? You ensure that it is Dockerizable. It is not maintaining any states within it, because if you have one application running here and you want to run a copy of that application here, you will have two different states managed. Now, as the previous factor said, if you are managing your states and backend services, it would be quite easy to manage states and manage concurrency. Then it would be very important to know that if you have your environment properly specified in your environment configurations and your dependencies properly specified in your, let's say, Dockerized or containerized environment, it would be quite easy to just copy that image out of one version that is running and deploy it on a different machine, because your uh, dependencies are properly mentioned. You have your backend services mentioned in your configurations. And if we are following build, run, release step properly, build, release, run steps properly, we have one image that is built prior to that existing application. So we don't have to build it again. It would be just copy this image and run it. And that is the whole idea of auto scaling as well in most of the systems, in most of the cloud systems. What they do is you specify the auto scaling policies. And if there is a load that this underlying infra is seeing on your services, what it does is it refers to the image of that application that you created, and spins up another infra for that and runs the application there. So it ensures concurrency. Then there are load balancers sitting on top of it, which are deciding where the request will go. So if initial service or initial infra had a quite big amount of load, then all the further requests, future requests will be going there, going to the new provisioned infra, I would say. Infra could be provisioned as new Lambda functions, or it could be new ECS containers. If we are talking about, if we want to use auto scaling for EC2 instances, which is just like a virtual machine that is provided by AWS. So auto scaling policies can also spin up new virtual machines for you, and it can ensure concurrency. But the underlying factor for 12-factor app says that your application should be able to scale out, right? Your code is structured in a manner that it supports concurrency. So if it wants to close, if it wants to scale, it can, right? It helps in like having the resilience to different workloads. Then there are different examples that are given here. So Kubernetes, which also is a service that facilitates running your containerized applications. Then ECS, as I said, from AWS, it is also a service for container running. So it can increase the number of replicas, increase the number of services, or increase the number of applications automatically based on the load. The key factor here would be to keep your applications stateless, and that's it, right? Coming to the next factor, which says disposability. Now, it again is a factor which talks about your application's processes should be able to spin and shut down gracefully. For example, if due to any reason, due to any crash or something, your application should not be having some state managed within it, which it required to process and it failed, and there is another functionality dependent on it. So any application that you are creating, it should be able to gracefully shut down, and it should have a fast startup. For example, if you are talking about the build dependencies, right? So if one service or one application closes, let's say if you had a server that is running and an application crashes, if you had to follow the all the steps from start to end, you will have to build it, then release it, then run. That would take a lot of time. And if you had stateful applications which had some data, it would be quite difficult if we want to dispose those services, because you will lose the state. Now, previous factors also enforce this particular factor that your application processes should be easily closed. We should be able to easily close them based on SIGTERM signals, which are from your host OS that can send out SIGTERM or SIGPL signals, and your application should gracefully shut down. Your other processes or other services should not be impacted by it. Now, how to ensure it? Again, as I said, keeping it stateless, keeping your build, release, and run stages independent, keeping your backing services for all the storage, storing states, keeping your environment variables, isolating your dependencies, right? And isolating dependencies becomes also quite important for certain systems where you can cache the build artifacts. So if you have some dependencies that you're downloading from, let's say, NPM repository for Node, or maybe from using PIP, so some build systems can cache those dependencies as well. So it will ensure that your application has your dependencies cached. You have your state stored in your respective systems, backend services, be database files, or anywhere. And if your application wants to close, it can close, right? It is not maintaining a state. The only impact would be the HTTP connection. Let's say you have requested for a service, requested for a compute process, and your server is processing it, and it fails due to any reason. So you should be gracefully sending out 500 errors, or if that service fails, HTTP will in any case time it. So your service gracefully shuts down. You should be able to, you should be writing your code in that manner. Again, different framework services that we have taken note here is for Node, PM2 is one of the services, which is process manager. So if your process kills, it can spin up new processes, or it can gracefully close it without interrupting the other services that are running. That is again the factor of disposability. Coming to 10th factor, which says a dev or production parity. Now, we have talked about keeping everything on our central Git repository, where we have talked about dev branches, QA branches, and prod branches. What it means is that your underlying infra and underlying code between dev branches, dev, QA, or prod, or dev to prod, I would say, should be as close, as similar as possible. If not exactly same, as similar as possible. For example, the, the database, if you are having Postgre in production, we should not be relying on Mongo on them. You could use a lighter version of Postgre, which is utilizing less number of resources. And there's a possibility that some developers might be using SQLite on their machines for testing and all. But what this factor says is that instead of relying on SQLite or let's say relational database on your machine, you should be having as close to production as possible. You should be having a system as close to production in your development environment as well. Configuration could be quite low because you don't want that much level of performance in there. Uh, but you need to ensure that your dev environment have all the similar things that are included. It ensures that whenever you build your images, which are built and released and stored in a repo, and you want to just release that image, which has been tested, you just release that image and it won't break on production, right? So if you have created an image or code on dev environment and you have created a release branch out of it, you have generated an image out of it, which relies on certain dependencies. If you are ensuring that same infra is there for production, but it could be scaled up, it could be having good enough resources, it will run smoothly. This is the 10th factor that says. Then 11th factor says logs. So you should be treating logs as streams. What it means that in let's say .NET or in Node, you can also write your logs to standard out, which is console log. You can write your logs to files. You can write your logs to a third-party logger where you're storing it. Now it says that your servicer should not be relying on third parties, should not be relying on files. It should only be sending out streams of logs to your standard output, which is your standard out. It could be console log, it could be std out, right? Now, what it would mean in cloud native applications is if your application is running and it is just streaming out logs, the underlying infra for that cloud service provider, there could be a log streaming or log fetching or aggregating service that might be running within that container or within that service, not with your application, but attached to that service. And that will be responsible for aggregating those logs. Your application should not be aggregating logs. It should not be responsible of managing logs. Your application should be just streaming out logs, whatever those logs be it error logs, be it warning logs, be it info logs, be it just debug logs, right? Application should be streaming logs, just sending out to console or standard output, and then the backing infra, or I would say the attached infra to that service, it should be responsible for aggregating it and performing any operations on it, be it searching, be it maybe sending out notifications. Examples are ELK Stack, which is Elasticsearch, Logstash, Kibana, which is a quite popular platform, then CloudWatch for AWS for log aggregation. Again, avoid local storage. And local storage, again, as I said, keep your application stateless and just stream out logs for the data which your application relies on. Keep it in stateful services or in backing services. For logs specifically, treat them as stream and ensure that you are sending out a stream. The last factor says the admin processes. What do you mean by admin processes? So, for example, if we take example of the initial thing that I said, that there could be some changes in schema, there could be some changes in the database, there could be some values or seed values or that you want to insert into your databases or perform some updates or patches to your applications. So these all are considered as admin processes. So what the 12 factor says is that these admin processes should not be part of your code, or it should not be part of your application. As in previous factors as well said, that application should be running independently in an isolated manner. It should not be responsible for a lot of things, including that logging, including admin processes. So admin processes should be running independently. If you want to utilize the same environment, a similar environment, then create one and run your admin processes from there. rather than baking the admin process related code into your current application. Right? That's what the 12 factor is. If we just want to recap, we start with code base in Git, dependencies isolated in different files, configuration in our environment values, not in hard-coded manner, backing services, which is attached services like databases, S3, caching, treat them as backing services, and we treat them as attached resources via environment values, build, release, run, different stages, keep clear separation between build, release, and run stages. Then processes, don't keep your application stateful at any cost. Keep them stateless. Ensure whatever state you want to save, you're storing in caches, databases, files, be it S3 or wherever you want to. Then port binding, your applications are not assuming what a port might be like. It should not make the other user guess which port it is running on. It should be exposing those ports, whatever port it is running, let it run on that port, exposed to the needed port. Concurrency, we ensure that our applications are not stateful and it can be spin up in parallel rather than requesting for a high compute resource or high level of infra. We ensure that application is running concurrently in parallel. Disposability, your application or your code, your service should be able to close gracefully. It should be able to spin up gracefully. It should not be abruptly doing some operations related to state and all. Uh, then dev prod parity, keep as similarity as possible between dev environments and prod environments. Scale down version of prod can be used as dev. And for logs, it needs to be stream rather than an action or a job that your application is doing. Just throw out streams and let the stream aggregator handle it. And for admin processes, don't enforce that onto your application or your process. Treat it as a different standalone one-off task. It could be in a different environment. But these are the all 12 factor apps. Now I am open to questions. So you can just type in your questions and I'll try to answer that in the create post. I don't know if I can enable the mic for everyone. Okay, I'm enabling mic for all the attendees. So you can try unmuting yourself and maybe if you want to ask anything, you can ask. Anyone? Anything? Either it was quite good or it was like quite bad because I don't see any question coming up. I'm not sure if you are able to send out questions or answer or maybe if you are able to unmute yourself or not. Okay, then if we don't have any questions, if you have any questions, you can reach out to me on LinkedIn. You can scan the QR code to reach out my LinkedIn profile, and the same URL is here. I have also shared some references where you can read more about these 12 factors. and you can just take a screenshot of it. I can maybe send all of these in the group as well. I'll send that in the chat. There is a question, will there be any risk if any of the 12 factors is not chosen? I mean, will it be good to have all 12 or any of the 12? So these are just set of principles, and I won't say there is a risk. There will be definitely risks in terms of performance, in terms of like security. If you miss certain factors, for example, if you are not ensuring your configurations are managed outside your application's code, there will be obviously security risks associated with it. If you are sharing your code, your credentials will be exposed. And we have seen many of these security breaches that relates to the hard-coded credentials and version controls. Because what happens is people forget that their credentials were in the code, and if they make it public or if they open the access to it, it gets vulnerable. Then the performance issues related to concurrency will definitely be there. If your application is not able to handle or uh, ensure that your application is running concurrently, there will be performance issues. If you are not having isolated dependencies, you will run into setup issues. So if you are sharing your code base to some other developer, they will have different host OS. Obviously, they could be using Mac, they could be using Windows, they could be using Linux, and then there could be different versions of the underlying frameworks that they might be using. So, for example, 14, 16, 18, so 20, there could be any, and they will be running into those build issues or setup issues. There could be risks or delays if we don't follow the proper build, release, and run isolation. So you will get stuck into uh, that phase that you will have to build it again. And for example, if we are talking about a simple application which takes 5 to 10 minutes of build time, it will have an impact on a daily basis. So if we are deploying to into dev environment, or maybe into production, 10 minutes is a big amount of time if your services are blocked, if your users are blocked due to some issue, and if you want to roll back. So there are definitely impacts that users will face. Thank you. Any other question from anyone? QA, I see. I think that I answered that. Anything else from anyone else?
Yeah, Pranveer, I do have one question here. Am I audible?
Okay, great. Thank you so much. Thank you for the patience. And if you have anything, just reach out to me on LinkedIn. I will be happy to help you. If you want to consult me for any solutions, I'm definitely happy to help. Thank you. Thanks. Bye.